Hello, welcome to my channel. Let's continue the 2013 MIT Integration B. This is the part 5, which is the last part of this series of videos. I will work on problem 21 to problem 25 in this video. If you miss the part 1 to part 4, you can click here or click the link in the description box under this video. Let's look at problem 21. So we need to deal with this fraction integral. And we can see for the numerator, the power index is 1, which is odd, so we rewrite it into this way. Then we can use the substitution. So we let u equals to x squared, and du equals to 2x dx. Then we just plug in. So we got an integral respect to the u. Then we factor it. Next, we do the partial fraction. So we convert it into the sum of two fractions. Then we replace it with the terms colored in green. So we got here. Then we split it into two terms. So we can integrate it and we got this result. Finally, we plug in the u equals to x squared. And here is the answer. And don't forget to put the absolute sign inside the log function. Here is problem 22. We need to solve this integral with respect to this square root function. So first, let's factor out this square root 3. Next, we use the trigonometry substitution and let x equals to 2 times sine theta. And then we can get dx, which is 2 times cosine theta d theta. Also, we can simplify this square root term into 2 times cosine theta. Then we plug them back into this integral. So we got here. Then we just simplify it. Here we use the double angle formula for cosine to theta. Then we plug in to replace this squared term colored in red. And then we just integrate it term by term. So we got here. Next, we need to convert this function from theta to x. Go back to our substitution. So we have sine theta equals to x divided by 2. Then we can solve for theta, which is arc sine x divided by 2. And from the trigonometry identity, we also can get cosine theta. So we use the double angle formula for sine function and write sine 2 theta equals to 2 times sine theta cosine theta. And then we plug in the expression for sine theta and cosine theta. So we convert this sine 2 theta into the function respect to x. Then we got here. So we factor out and simplify it. Here is our final answer. Now let's move to problem 23. So for this integral, we need to deal with the trigonometry functions with high powers. But we observe that all their power index are odd. And if you note that here, the derivative of secant x equals to secant x times tangent x. So we can write it into this way. Next, we take one term from the secant x to the power 5 and one term from the tangent x to the power 3 and group them into this way. Now we can replace these red terms with the d secant x. So we got here. Next, we will deal with this tangent square term. We can use the trigonometry identity here because 1 plus tangent square equals to secant square. Then we plug in. So we can replace the tangent square with secant square minus 1. Now we are ready to use the substitution. We let u equals to secant x. So we convert it into an integral respect to u. Expanded, and this integral is easy to solve, and we got here. Finally, we replace the u with secant x. So here is our final answer. Now, let's look at problem 24. So here we need to solve a definite integral. But the integrand is not easy to deal with because we have sin x in the denominator here. So we play a trick here by multiplying 1 plus sin x and then divided by 1 plus sin x. In this way, the denominator can be rewritten into 1 minus sine square. So we got here, the denominator 1 minus sine square equals to cosine square. And then we split it into two integrals. But note that the second term vanishes because the integrand is an odd function. So we only need to deal with the first term. And for the first term, the integrand is an even function, so we rewrite it into 2 times the integral from 0 to pi over 4. We integrate it, and the antiderivative is tangent x. And we plug in numbers. So here is our final answer. Finally, let's look at problem 25. Again, we will deal with an integral respect to the fraction, and also we have square root in the denominator. Note that we have x in the denominator, so the power is 1, which is odd. So we multiply x on both numerator and the denominator, and we rewrite it into this way. Next, we use a substitution. We let u equals to the square root x squared minus 2. So we can solve for x squared, which is u squared plus 2, and x dx equals to u du. So we plug them back into this integral, and we got here. And note that the u cancel out. And we got this integral respect to u. And then we do another substitution here. Let u equals to square root 2 times t. Plug in and we got here. Factor out the 1 over square root 2 and we got an integral respect to t. The antiderivative is arctangent t. Then we replace t with u divided by square root 2. And finally, we plug in u equals to square root x squared minus 2. So we got here. And here is our final answer. That's all for today. We have done all the problems for the 2013 MIT Integration B. I will do another series of videos for 2014 MIT Integration B, maybe in 1 or 2 weeks. Thank you for watching. Please subscribe my channel if you like it.